All right, so the session has started and we are recording right now. Docker, can someone tell me what is Docker? What is Docker, boys? Software virtualization. So if Docker is software virtualization, then what is containerization? If Docker is virtualization, then what do you call containerization? Why are we terming containerization in the Docker product? Docker is containerization. Okay, but you said software virtualization. Is VMware not software virtualization? Is not Hyper-V software virtualization? KVM, right? So in a nutshell, Docker is a name of a company, right? If someone comes and tell you, hey, do you know Microsoft? You will say, hey, I know Microsoft. Microsoft is a company. What product are you referring to, right? Are you referring to their operating system, right? Are you referring to their database that they have? Are you referring to their cloud services? If someone comes and tell you, do you know Oracle? You will say, yes, Oracle is an organization. They make Oracle database. They make business applications. They make CRM. They make 50 different things. They have operating system called Solaris. What are you referring to, right? So if someone comes and said, you know, SAP, right? You say SAP is an organization. They make CRM. They make ERP, supply chain management, right? Half a dozen different softwares that they make. So Docker is the name of an organization which makes container and containerization products. Let me rephrase. Docker is an organization which makes container or containerization products. Just to give an heads up here, we'll go to Wikipedia. Docker. So Docker is a computer program that performs operating system level virtualization, which is also known as containerization. Right? So container, containerization, swamp manager are products of an organization called Docker. Are you getting my point? Right? So like we have, so let me put an architecture here for you to give you more clarity here. CPU, RAM, storage. This is my network, right? And the layer that I'm trying to deploy the layer, this layer is called virtualization. So what are you virtualizing here? You're virtualizing the hardware. And therefore it is virtualization. There are a lot of products which does virtualization, right? EXX from VMware, Hyper-V, KVM, right? Xen, couple of others. So these are the virtualization product which virtualizes your hardware and present them to your operating system. This can be Linux, this can be Windows, Linux, right? Something like this. So what you have is you have this thin layer here. Let me make this small. So you see this yellow line, right? This is a thin layer called virtualization, right? Which takes your physical hardware and simulates into a virtual world, right? There's a marginal performance penalty. There is a performance penalty because there's a software on top of another software, or you can call it as a VM on top of another VM, right? The reason why, because the virtualization platform is nothing but your operating system, right? It is repurposed to do a different thing. It is repurposed to host tenants or guest operating systems on top of it. But at the end of the day, it is an operating system by itself. So there's a primary operating system and there's a secondary operating system. That could be a right term to coin, right? Docker is containerization. Okay. Now on top of it, you make another layer. Now this layer is called containerization. Let me copy this so that I can get this spelling right. So this layer is called containerization. So what you're doing is you're further virtualizing your OS. You're further virtualizing your OS, right? And then you're building your environment here. You're building your containers on top of it. Right? You can have something like this. You can have more than 3 containers here just to represent, right? Something like this. So what I'm trying to articulate here is, right, you have the hardware layer, you have the virtualization layer on top of it, and then you have your operating system, right? And then on top of your operating system, you containerize it. You need not have to have all the operating system. If you only have one VM, you can still containerize, right? In Microsoft world, we call this concept as nested VM, a VM on top of another VM, right? And in the Linux world, we call it as containerization or containers. And the environments that I have marked here is called containers here. The yellow line that you see is called containerization, which is sandwiched between your operating system and Docker. And all these small environments that we have, these are all Dockers, right? Why are we doing this and what problem are we trying to solve? Let's understand that, right? First is migration, ease of migration. Because whether you work with AWS, Azure, Google or Alibaba, any other cloud platform that you have, because your containers do not run native to the platform itself, they run on top of an OS. So Windows are available across all the platform providers. Linux is also available. So if you package this application to run on an operating system, it will be easy for you to just lift and shift or migrate from one data center to another. Advantage number one. Now advantage number two is microservices. In our first class, in our second class, third class and all, we deployed applications, we created websites, we hosted web pages on Windows machine, we hosted pages on Linux machine, we installed and built the e-commerce platform, right? We did CRM project, we did WordPress project, right? Now those applications are called monolithic. What is monolithic? Something which is together. For example, a cake. You go to a cake shop and say, hey, give me a cake. And he will give you a 1 kilo cake, right? A big pastry, he will give it to you. That you will bring home and you will celebrate your birthday, a child's birthday. And while you're distributing, you'll cut that into smaller pieces. Right? Before cutting the cake into smaller pieces, the whole cake is called monolithic. That means a one big cake or a combination of multiple pages of code. Because that cake will also have multiple layers. Cream will be there, something will be there. There's a bread inside, right? There's a sauce inside, sweet sauce. There are dry fruits inside. So there's a layer that is packed into it. It is a monolithic. Combination of several ingredients have made that single cake. So that is monolithic. So likewise, OpenCart is monolithic. It's a single application, collection of codes, collection of pages that are put together. It's a monolithic application, right? Now what happens is when you're using an application and if your application goes down, right? If somebody accidentally keeps a hand on the table, the whole cake will fall down. The whole cake will fall down and then you lost the cake. So if something happens to your application crash, your environment wouldn't be available, right? But if you chop those cake into smaller pieces, if you make it small pieces and somebody accidentally touches that cake or he puts his hand, right? Few pieces of the cake will fall down, but most of the pieces will be retained on the plate. Right? So likewise, if you take a large code and if you chunk that and if you make smaller pieces down, right? Few containers fail, it is okay. Your whole application will still continue to run. Some part of your application or some function of your application may not be functioning or may not be available. right? So you take a big cake, you cut it into smaller pieces. Likewise, you take a big software, you chunk it into smaller, and you call it as microservices, right? Home page is in a separate container, your registration page is in a separate container, your login page is on a separate container, your order page is on separate container, your product page is on separate container. You're getting my point, right? So you microservice, or you split this into smaller pieces. This is microservice. Now the third thing is, right, parallel. So what is parallel? Now, if you want to install a software on your laptop, right? So while installing a software, at some point it will say, hey, a copy of the software is already installed. Do you want to repair this software? Do you want to overwrite it, or you want to upgrade it or uninstall it? Have you seen this message, right? So several times happens that, you cannot have a same software, two instances or two sessions of the same software installed on your computer. Try doing this with Firefox, right? Or Internet Explorer or Chrome, Microsoft Word, Excel, PowerPoint, Skype Messenger. You cannot do it. Even on your phone, you will have one Facebook, one WhatsApp, right? All applications, bank applications, you can only have one instance of those applications running on your phone. But if you want to run two WhatsApp or two Facebook, you need to parallelize. There are features that are available where you can parallelize your phone operating system that will allow you to install two WhatsApp. So likewise, when you say parallel, this will allow you to install multiple instances of the same application or a different version of the application. Why is this big deal here? Now, if you want to physically test this software on one laptop, and if you have version 1.1, 1.2, 1.3, 1.4, 1.5, then you need 5 different laptops to test. There's a huge cost involved there. Forget about physical world. Let's talk about virtual world. You need at least 5 Windows or Linux machines for you to test 5 different versions of the software, right? But instead, if you could just have one laptop or one operating system or one phone, and if system allows you to have multiple instances of the same application where you can parallelly run those applications, not interfering each other, isn't that amazing? So this is the third use case that container tries to solve by parallelizing the application for you, right? And fourth thing is OS life. OS life, right? Why is this important? Hey, OS life, why this OS life is important here, right? So when you buy a brand new laptop or a phone, initially it is fast. After a couple of installations, reinstallations, your operating system will become sluggish and slow. So developers would have a variation in result. When your operating system is fresh, you have a different performance and different result with your application. Over a period of time, when your when your OS becomes sluggish and slow, when you run the application, there's a different result there, right? Now, hence to mitigate this, you want to absolutely make sure that if you install the first time, or if you're installing the application the 100th time, right, the result should be same. So you should ensure that the operating life cycle or operating system life is intact. Are we clear so far? Are we clear so far? Yes, no, maybe. Who has doubts? Okay, everyone are clear so far. Nice. Now, right, so there's already a performance penalty because there's a virtualization platform that you have, which is sandwiched between your hardware and your operating system. And there's another virtualization or a containerization platform between your containers and your Linux operating system or a Windows operating system, right? So there is a more performance penalty here because there's too many layers of code on top of each other, right? But if you could trade off that performance, that 8-10% performance degradation, right, the payoff is heavy. The payoff is migration, ease of migration, microservices, parallelly able to run that, cost savings, and you can ensure that your operating system life is intact, right? Now, what is container? What does container has, right? What does a container actually has, right? Container is nothing but an operating system, but it is a cut down version of operating system. It is the exact same Linux, or it is the exact same Windows, It is just that it is extremely stripped down, super stripped down. When I say stripped down, right, it does not have a storage controller. Because it does not have a storage controller, it has to rely on the underneath operating system to communicate with storage. Right, it does not have a storage controller. It does not have network drivers, so it cannot talk to the network by itself. It has to use the underneath operating system to communicate with the network. So there's no network stack available. In fact, these containers do not have kernel, so they cannot do thread management with processor or paging with memory. So basically, you should think it is an operating system head. It does not have a body or tail. Right, so what it basically does is it will trick the application to think it is running on the full operating system, but it will be running on container or on an operating system head. Just to give you an example here, this is not the image that I want to. Okay, this is, I think, a clear depiction, right? So if you see all these heads, these are all the containers. This is the body is full Linux operating system. This body has storage. This body has access to storage, network, can do talk to memory, CPU, all that this body can do, right? But these are all the operating system heads. These are all containers. Right. For example, if this container has application version 1.1, this has 1.2, 1.3, 1.4, right? And they're required to talk to a network or a storage. They just have to go to the main operating system body and communicate. Are you getting my point? Is it making sense? I cannot make it any more easier for you to understand. So every time when you talk about container or containerization, think about this image and think that all this is our containers and this is an operating system on which it is running. Are we clear? Okay, excellent. Let's go back to the Excel sheet, right? Okay, so in today's lecture, right, we're going to work with a service called Elastic Container Service. Right, there are a couple of other services such as Elastic Kubernetes service. There is also a service called Farigate, which is a proprietary service from AWS by themselves. Right, so there are a couple of services that are available, but the most popular is container. So I'll be covering that in today's lecture. Right, so the first step, what we need to do is we need to prepare our jump box. We did the jump box yesterday also, today also we're gonna do, and this is gonna be my EC2 Linux machine. Now this Linux machine is connected to, what is it, what is my jump box is connected to? What is my jump box is connected to?
Code commit.
Exactly, a repository code commit, but today we will be using a code commit like service specifically designed to host Docker images. It is called Elastic Container Repository or Elastic Container Registry, ECR, which is like code commit or GitHub, right? After this, it will be connected to my cluster. So cluster is nothing but EC2 Linux machine. After this is connected to tasks. So what task will have is it will have container size, repo URL, and then services to configure this. So this is our assembly line, right? Guys, did you guys work on CodeStar yesterday? Do you like CodeStar? I failed to do it. What happened with CodeStar? What was an error message you had? The deployment failed because no instances were found for your deployment group. I think you have to create two EC2 instances and you have to add EC2 instances to code deploy. I think you have not added instances to code deploy.
No, I did
Ch-
it. I did it.
just to make
I
sure
did.
that, but you have not tagged it correctly. So while creating a machines, your tags may not be correct.
Okay, okay. It might be. I tried 3, 4 times, but I'm continuously failing.
Tag
So
it properly, na.
okay, okay. I will try it
Tag it
again.
and try.
Hmm.
An auto-scaling group correctly identify the instance that you want to deploy. You have to tag it, buddy. Okay, let's continue then. Right. So again, to connect one or more AWS services, we will use IAM role. So we'll first create an IAM role before we could create our jump box. Services, IAM. Roles. EC2. EC2 again. So container registry full access and container service full access. Name. And then you click on create. That's it. EC2. Let me do this in Mumbai. Launch instance. Amazon Linux. Configure instance settings. Shiva, I think that the other person was Shiva. Shiva has done the lab. Code deploy lab. Shiva, did you had any problem completing code deploy lab? I think it was you. Who was it? Saddam, I guess. Right. Saddam has completed the lab. You did not even publish the page, Saddam. Where is the page? Half of work is done. Okay, so EC2, just select this IAM role. Add storage, 8 GB is fine. Jump box. Again, I just need port 22. That's all I need here. And then I will launch. Okay, my bad. It is still initializing. I'll give a couple of minutes here. Okay. So I'm gaining the privilege of root user here. Now there are a couple of things that I need to install. First is I need to install git CLI, and we also gonna install Docker CLI here so that we can run or execute Docker commands. We can build packages. All this we can do on this machine here. So yum install git -y. Okay. So this will install the git package. I'm just going to replace git with Docker. User mode -a-g Docker root Okay, so let me explain what I'm trying to do here. Like, to change any file permission, if you want to change any file permission, you will do change mode, ch mode, and then you give 777776665 to give appropriate permission to your file, right? And in case if you want to apply the permission to subfiles and folders, you will use recursive -r. So capital R with an hyphen is what you will pass a parameter to ensure that it applies the permission to all the subfiles and folders, right? So likewise, what I'm doing, I'm doing the exact same thing with the user, but slightly different, right? I'm modifying the user state here by running a user modify command. So, right, user mod, right, and then -a and -g, right? So user mod -a, I'm adding to a group -g to a group, and group name is Docker and user is root. So I'm adding root to Docker. So likewise, user mode -a means again add where to the group -g group, and the group name is Docker, and I'm adding EC2 -user there. I think I'm getting older. So now I have started the Docker service, so I'm ready. So do I have anything here? Nothing. So I need a software or a package, right? We'll go back to the GitHub repository to download a package here. So there's an ECS tutorial. Click over here, clone, copy. Right, the same command that we will run here. Git clone and the URL. Now if I do ll, I have a package. Let's dive into the package to check what we have here. Right, there's an Apache package that is available as a Docker file. And if you read the Docker file, right, it's a manifest file for AWS series, where the first command says to update, the second command says to install Apache 2, right? And then set up Apache. It is creating an Apache user into this directory. It is also putting the log onto this directory, right? It is locking the log from this directory, right? And your PID services here, right? Put the HTML page. So it is passing a parameter and is giving /Apache index.html. So there's a file in Apache directory. If you see, this is the Apache folder. It is telling copy the index.html file from the Apache folder and position it here. This is the location that is asking you to put. And third thing is there's a supervisor config file which is created into the supervisor directory that is here. It is asking to put this under config, right? And expose 80, it is basically telling open the port 80. A simple script which has been written by one of the developer, right? So like this, your developer will write and give you some script so that all you have to do is you have to lift and shift. So you pick it up and you deploy this there, right? So now I have the package ready. Let's dive in. Go back to services, and if you see here, you have Elastic Container Service, Elastic Kubernetes Service. Elastic Container Service. What is this ECR? Amazon Amazon Elastic Container Registry. Easily store, manage, and deploy container images. Okay. And there's one more repository here, ECR. There are two times they have given. God knows why. My repository, I'm gonna call this Hello World. And then I'm gonna create a repository. It is like code commit. So you can give whatever name you want and your repository will show up. Right now the repository is empty. Right, and there's a repository URL that they have created. Now, where did you go instructions? Okay, never mind. View push commands. The commands are available here. So the first command says to log into Docker repository. So I'll copy this. Go back here. And I will paste it here. So it is basically asking me to log into the Docker. So it will use that IAM role that I've associated with this Linux machine. And with the help of that, I will be logging in here. It says I have logged in successfully into that repository. Now the next step is I have to build the package. So I'll copy this command, paste it here, docker build -t, right? And it is giving the repository name that I've created. You can change the repository name, and dot represents that Git file. I'll hit enter. It'll start building now. It is building a Docker image right now. Okay, now finally I have to push this. If I come down here, there's a tag command. I can tag this to my image, tag it as latest, and finally the last command to push. Now I'm pushing this to the Elastic Container Registry. That's it. If I come back here, where did I go? So the code that I downloaded the code from the GitHub to this machine, and I moved into this machine. Right? Basically, I moved the code to the services that I have here. Let me color code this. Now the code is available, and you want to take this image and deploy it on this cluster. That is what you want to do right now. Close. Let me. And if you see here, image name is latest, and the code is moved here, and it was moved 39 seconds ago. And the package size is 105 MB. This includes the Linux operating system, the operating system head, and all the middleware such as Apache and the Hello World web page. Now let's go and build the cluster. Right. Opt in to new area resource format. Okay. Create cluster. Now there are three options that are available. Network only, right? Powered by FortiGate. And then you have Linux and you have Windows. We're going to work on Linux today. Next step. And make sure you change it to T2 Micro. T2 Micro. You can give as many as you want. I'm going to demonstrate with one instance. 22 GB is fine. I'll select my key pair. VPC I'll show you in another class. I'm just selecting the existing subnets here. And I already have the security group. This has both port 80 and 22 opened. So I'm going to select this here. Right, and then I'll click on create. So basically what this is doing is going and creating an EC2 instance for me. Right, like Beanstack. Right, what Beanstack did is it went and created an EC2 instance, and that is what it is trying to do right now. First project, ECS instance. Still no instance here. Now if you see here, it is doing its thing. It is bringing up the instance right now, and this was created by ECS service. Let me do another refresh, and there you go. It gave a tag also here. Right, let me do another refresh here, and there you go. The instance is showing up here. Right, so that is what cluster means. You can define how many instances that you want. Right, the third option is task, where you defined the configuration for these instances. Right, I'm going to select EC2 here. Price based on resource use, multiple network modes available, self-managed infrastructure. This is AWS managed infrastructure. Next step. Task to build. Doesn't need it. Don't need it. Okay, total memory. Now you need to remember there's a calculation available here, but I will explain you. 1 GB memory equals to 1024 megabyte of memory. Likewise, 1 core CPU is equal to 1024 core units. Right, so the underlying instance that you have, you cannot allocate all the memory to the container. If you allocate all the memory to the container, the instance will crash. Instead, you have to at least leave some amount of memory back to the instances, and you have to reserve the rest. So what I will do is 1024 minus 25%. 25% I will allocate to my instance, 256. So remaining is 764, 8. 75% I will take 768 and 768. Add container. Container name is hello. Hello world, and it is asking for the image URL. Services, Elastic Container Service, repository, and then copy the repository URL from here, and then you paste it. So what you're trying to do is you're trying to specify the container size here, and then you're giving the repository URL. When it's a repository URL, you're giving this ECR URL right here so that this task knows exactly what container and what package that it needs to deploy. Can someone tell me the difference between soft limit and hard limit? What is the difference between a soft limit and hard limit? I am working on incident. I will join you later. Not come to class 11. I will do it tomorrow. I have. I'm doing still not yet come. I'll share it tomorrow. Soft limit means varying. Hard limit means absolutely correct, right? So soft limit is where your most of the time your Docker will reach, right? But it will have a buffer to further go up and access additional portion of the memory. But even more memory if it wants, right? You don't want your operating system to crash, or you don't want your other containers to suffer. Hence, the container will fail. You're absolutely correct. So just given a teeny mini portion of this, and I'm doing port mapping because the application that I have on the Docker requires port 80, and the port that I want to use on the instance is also port 80. Right? Again, CPU. What I will do is I took 786. I will just select 7 here. Right? 0.1% is what I'm selecting. Add. Now, if you see in the graph here, though I have taken 768, I'm only using teeny mini, which is 96 here, and 704 shades are still available. Likewise in the CPU also, I have lot of shades available where I can add more containers on this instance feature. 8, 9, 10 more containers I can add with different applications or with the same applications on this instance. So therefore I'm reserving the capacity here for additional containers that I'm going to add in future. Create. My task is created. Lastly, service. Create a service here. So basically what service is going to do is the task configuration that you have allocated, right? It will use this configuration, and on this cluster it will deploy the container. It will take the container size, it will create that size here, it will take the URL, it will deploy the package also here. Let me show you in action. Deploy. There are two types of services available. Replica service places and maintains the desired number of tasks across your cluster. So if you say 1, that means it will ensure that one portion of this container is maintained all the time. Daemon service places and maintains one copy of your task on each. If you have 5 instances running, it will try to take that container and put it on 5 separate instances. Right? That is daemon. Replica means only on one machine. Number of task 1. Next step. I'm going to use my existing VPC here. Create a new namespace. Discovery server, select an existing, deploy. Okay, next step. Next again. And then you create it. The service is getting created now. Wait, failed. Directory services, create a directory service. Previous. Enable, disable. Next again. Create service. Refresh. Cluster. So it is right now pending. We'll give couple of minutes so that this service that we have created right now, can do its thing. It can take the task configuration and deploy it in a cluster. That is what it is doing right now. So we'll give couple of seconds and then we will try again.
Yeah.
Let me refresh now.
I have a small question.
Go ahead, buddy.
When we create the EC2 instance, we select the T2 micro, and like that we have other also like R4, P2, M5. These have any meaning? Like what?
Yeah, there is a meaning.
What?
There's a meaning. So if you come here on EC2, click on launch instance. Simple elimination that you select here, right? So T2 or a tier 2 is basically means a general purpose.
Okay.
Right? T2 is the second tier, not the first tier, right? This is medium tier.
Okay.
Right? And this is large, extra large, right? So basically this represents, when you see C, that represents it is optimized for computer. When you see P, performance, GPU, right? When you say R, it is for memory, right? For example, if you go to Virginia, you can also find T1 instances there, which is the previous generation instances. Launch. Select this. See, you have T3 also here. T3 versions are also available and T1 is also available here. Let me go previous.
T2 means it's generally like the tier 2, no?
Yes.
Okay. And it's used for the general purpose instances.
Yep.
Okay.
Continue. See, you have A series also here, A1, A2, A3, which is not available in Mumbai. I think they have removed T1 micro here, but typically in Virginia region, some instances usually come with T1 micro also,
Okay.
right? Which is a previous generation of that. But the best way to understand is you just go back and see what it meant for RP, performance, GPU oriented, memory oriented, because of compute resources, and you will get your answer there.
Okay.
And if you want to read more synopsis, you can go to aws.amazon.com/EC2, right? And then you have instance type here, instance types, right? And they'll give you synopsis here.
Okay.
General purpose, accelerator, memory, right? A1, T3, T2, MS, right? T3A. So it'll basically tell you why it is meant for, what it is used, and how many instances that you have in its family. Okay, so let's dive back in. It seems it is ready. Let me open the cluster. Copy the public IP address. The project should work now. And if you see here, it is running hello world. That means the index.html page that came with the container is actually published. But let's log in and check whether it is running on a container or it is whether it's running on that Linux machine itself. New session. SSH auth browse. Open. EC2-user Docker images, Docker print services, and there you go. And if you see here, you see the repository that we used to bring the package is right here, right? And this is running on the container, and this is the container details. So that means it is running on the container which is running on top of that Linux machine, right? So like this, you can deploy multiple containers here, but remember, this is a fully managed container service by AWS. Like any other services here, we do not need Docker administrator. There's no Docker administrator that we need to orchestrate or manage this. Amazon has automated that for you. The only thing that you need to worry about is functional work. How do you put package? How do you take out package, etc., etc., etc. Right? And this is a very common story across most of the AWS platform use cases. We saw this in database. We saw this in Active Directory. We saw this in Workmail. Right? We saw this with virtual desktop when you created Windows 7 and Windows 10. And hey guys, you have not done Active Directory lab. You have not created virtual desktops. I haven't seen anybody publishing that screenshot. Right? So all this is managed service. So Docker is also managed service in AWS. Like database is in Ocean, right? Active Directory is also in Ocean. Docker is also in Ocean from an administrative perspective. But this is the nature of cloud, and this is where the world is heading into. All the work will be automated here. Are we clear? Yes, 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 no, maybe.
Can you once again repeat about your Excel sheet, the flow of that all the Docker? Because it's a little bit confused actually. I could not get properly.
You create a jump box to download a code from GitHub repository, and then you will use the same jump box to move to your internal repository called Elastic Container Registry. Right? So what you do is before moving the code from here to here, you will do the build activity. You will build the Docker image, and then you will move this here as an image. Once the image is moved, you want this image to run somewhere. So what you will do is you will look for an underneath infrastructure. So you will use cluster, and then you will provision an EC2 instance. So now you have the environment ready, but you still cannot put this image right here because you need to configure Docker on this machine. You have to configure the Docker size, the container size, right? Amount of CPU that you want to allocate, the amount of RAM that you want to allocate, right? So once you launch this cluster, you go back and create a task stating that, okay, my server has 1 core CPU and 1 GB RAM because it is micro. And then you say 75% of your CPU and memory you will reserve to add multiple containers, and 25% of your resources will be left back to your instances so that your instance can function correctly. So once you have defined the container size for your first container, you will also include that there is an image that is sitting here by copying the URL and pasting this in your configuration of your task. Once you have done this, you just have to go and tell the service, hey, this is configuration number 1, this is configuration number 2, this is the configuration number 3. Pick up this configuration, put this on a instance number 1 or instance number 2 or instance number 3. And what the service does is it picks it up and deploys it here. And as soon as it is deployed, you just have to copy the IP address and run it on the browser to test whether the container was successfully deployed. And optionally, you can log in like I did just to make sure that the application that is published is actually running on the container, not on the instance itself. Clear, Mahesh?
Yeah. Okay. Yeah. Clear. Yeah.
Okay. Right. So let's continue further here. Right. So in today's lecture, I'm going to also discuss on, we're supposed to do auto scaling today, correct?
Yeah.
Okay. So let's do auto scaling. There are three prerequisites that you need to understand before you construct your auto scaling use case. First is you need to have a custom AMI you need to have, which is pointing to database endpoint. Right. I have showed you in multiple classes on how do you connect to the database and how do you capture an image. The next thing that you need is a load balancer. And the third thing that you need is a size. Right. So when you're doing auto scaling, right, if you're selecting micro, every time you auto scale, a micro machine will be added. Just to give an example here, let's assume that this is your EC2 instance, right? And let's assume that this is your RDS database. This is my master. This is my slave. And you know what will happen? Instance 2 will also talk to master. Instance 1 will also talk to master, right? And if your master fails, your slave will take over. Now, in case of an auto scaling, what will happen is it will not dynamically increase CPU and memory. I think one of you had a question at the beginning of the class. I think it was you, Saddam, that asked if I want to scale up, can I add CPU or a memory in a running machine? The answer is no, you cannot do that. Instead, when I mean auto scaling, basically what will happen is, right, I have 2000 people, so 1000 is here, 1000 is here. So there's a third 3,000 people who will come in, another 1000. So what usually does is, in case of an auto scaling, it provisions additional instance for 3000. If it is 4000, provisions the additional instance. And because you're giving custom AMI, which is already pointing to database, and the new machines that are coming in are just clone of the existing machine that you have. As soon as the new machines are launched, it will automatically start talking to your database because you already have endpoints configured into your application, right? So when the traffic comes down, it can scale back, it will become 3000, further it will become 2000. So your instances that you're adding up in the pipeline will also start be deleting it, right? So let me show you this in action so that you guys can understand how an auto scaling works. The request CRFS token is invalid. I would not be needing a jump box here, so let me terminate that also. And Elastic Container Services, task definition, deregister. Okay, EC2. So we'll go back and we'll start working on the blueprint. Where am I? I'm in Mumbai. So we'll start working on load balancer first, and then we'll go to custom AMI, assuming that we already have created custom AMI. I think I already have this AMI. Let me check. Okay, I have deleted the AMI. Otherwise, the AMI should be available. Never mind. I'll show you with the standard image then. Load balancer. create a load balancer. I'm going to just create an empty load balancer first. Create auto scaling. Both the availability zone. Configure security group. I just need this. I've explained you this in the load balancer class, and I don't have any instances here, so I'm going to just create an empty load balancer. My empty load balancer is created, and if I go to target group here, and if I go to targets, I don't have any instances. I've still not worked on any instances. Now launch configuration. Create a launch configuration, and now if you have an AMI created, technically your AMI should show up here. Since I don't have it, I will use something with OpenCart. There's a bitnami image that is available. I will use this here. Select, and size matters. We discuss about size here. This size matters because every time an auto scaling happens, you cannot have a different permutation and combination. Like your primary instances are small, but your auto scale instances are large. That you cannot do. If your primary is micro, then all your instances that you add will also be micro, right? So what is a maximum limit, right? In my account, I have only 20 micro instances that I can create. So the maximum auto scaling I can do is on 20 instances, right? Your account might vary. Auto scaling. Enable CloudWatch. This step is very important. 10 GB is fine. I'm going to select the existing security group. Review. And then you create the launch configuration with the key pair. Right? And now we're creating a group here. And how much instances do you think we should start with? What is the minimum instances that we need to use auto scaling with? Give me a number, boys. Exactly, Shiva, you're right too, right? The reason why too, because if you have one instance and if one instance crashes, it'll at least take minimum 1 or 2 minutes for your additional instance to pop up, right? So if you start with minimum 2, if you have one instance down, you'll always have one more instance added to it while the other instance has been restored, right? If you start with 1 and the one crashes for at least 1 or 2 minutes, you will not have any resources. So minimum is 2, bare minimum, but you can always start with 4 or 6 or 8 to ensure that you always are highly available and you have that redundancy. I'll select both the subnets here so that my instances can float on both the machines. And then receive traffic from the load balancer. And if you see, my load balancer is right here. The reason why I'm selecting the load balancer here, because every time a new machine adds up, right? If I go back to my Excel sheet, if new machines are adding up, right, you want them to be automatically registered into your load balancer. Right? So what load balancer does is 2 machines are overburdened, new machines pops up, the load balancer will auto register and start sending traffic to them, right? And once the instances comes down, it'll remove it, right? When the auto scaling comes down, when instances goes blank, right, they delete it, but your load balancer will continue to send traffic. And when traffic comes back again, new instances are popping back in, it is auto registering into a load balancer. So this cycle will continue and this will happen unattended. So therefore you have to say receive traffic from the load balancer and then send it to instances. So if you have 20 instances, because they are behind the load balancer can continue to send traffic to all 20 instances. Right? Minimum 2, maximum you can keep as much as you want. I'll keep it 8. So minimum to maximum 8, right? This you can decide on based on the instances that are available. And then I will set up a rule, scale up rule and scale down rule. So in my scale up rule, I'll create an alarm here, and I will say if my instances reaches 70%, right, you add one instance. You add one instance. You can say add two instances also, and this means plus 2, plus 2, plus 2. So it'll do an increment of two instances. If you say 1, it is 2 plus 1 plus 1 plus 1. So it will do an increment of one instance at a time once your traffic reaches 70%. And how soon you want this? Sometimes what happens in your production environment, your CPU will touch 100% for like 30 seconds. And then your CPU will fall down to 40%. Again, it'll go back to 90%. Again, it'll come back to 60. Again, it'll go back to 70. Again, it'll come back to 30. Because based on the traffic dynamics, it can scale up and down, right, with infrequent intervals. So what basically you're explicitly mentioning is, hey, if my instance stays 70 plus on CPU utilization for 300 seconds, which is 5 minutes, only then you add one machine. For 5 minutes, if within 5 minutes, if the traffic comes down, there is no need of creating a new machine and adding it into a mix, is what this sentence means. I will change it to 30 seconds because I'm doing a lab, so I want to crash the instance and I want the instance to come back soon. From a lab perspective, I'll keep it for 30 seconds, but make sure that you at least keep it for 5 minutes. This is a scale down policy. If my instance falls below 40, if my instance falls below 40, you terminate one machine. So you can say 2 here. If you say 2, minus 2, minus 2, minus 2, that means it will bring two machines down. But if I say 1 here, minus 1, minus 1, minus 1, and it's gonna bring the machines down. A quick summary on what I have done right now, and then I will create auto scaling. Now I've done nothing, boys. If I go back and check here, under my EC2, you will see two instances will be popping up. See, I did not do anything. Two instances are coming up and auto scaling is bringing this machine. Auto scaling is bringing this machine right now. Activity. And if you see two instances are coming up based on the scaling policy that I have determined. And if you see here, minimum 2, maximum 8. Default cooldown is 300 minutes. That means if you terminate an instance, or if you want to bring the instance down, it will wait for 5 minutes before bringing the instance down. You can always change this parameter. You can come back and you can change it here. You can make it 30 seconds so that within 30 seconds the instance can come back. Right, and in terminate policy you can clearly mention old instances that you want to remove or new instances that you want to remove from the VIX. Right, and then you can save it. Let me go back. Still initializing. So I'm going to show you two use cases. One is I will crash one of the instances and the auto scaling will self-heal. That means it will bring up another machine on the machine that it has lost. That is the use case number 1. Use case number 2 is I will not destroy or trash a machine, but I will take the machine to a point. I'll create an artificial stress so that an auto scaling can pump in. We'll give a couple of minutes here for the machine to come up and settle down. I think we're almost ready. Let me do another refresh. Okay, this is still initializing. Okay, right, both the machines are ready. All I will do is I'll terminate one machine. Believing that the machine is lost due to traffic or spike, and the auto scaling will kick in and it'll recreate another machine. So I will not be doing anything here. The system will do it. And while the machine is getting terminated, let me also show you the load balancer here. Target group, target, and if you see, one instance is terminated, the other instance is automatically added. When we started creating, we created an empty load balancer, but the instance is already added. I wish I could have showed you before terminating it, but since the machine termination has started already, it is automatically drained or removed from the load balancer. Now, couple of minutes, a new machine will be added and I will show you in your load balancer. Activity. If you see here, it's draining the traffic. It is terminated, so I will not be doing anything. In 30 seconds, a new machine should come. And if you see here, the new machine is initialized. I did not do anything. The auto scaling is self-healing or basically adding a machine here. Okay, guys, can you hear me? I think I got reconnected. You can see my screen also, right? Okay. Just checking. Still initializing. Let's go back and check whether this machine is added into the load balancer. Target group. And if you see here, the new machine is added. It is still initializing, but if you could see, the new machine is added into a load balancer. We'll give a couple of minutes.
Behind the load balancer, these are all application servers, isn't it?
Yes.
Web servers.
Yes, that is correct.
Okay, but
And
if the web servers, the code has been updated or there is some changes, then how it has been applicable to all the instances?
so you have to use code deploy. I showed you code deploy. You use code deploy with auto scaling, so that if you have instances, right, it can go and update the code in the auto scaling instances also. See, basically what happens is, one image, if you update it, when the auto scaling happens, it's just going to pick up the updated image, it's going to deploy it. So you can always create an auto scaling and you can replace with an old auto scaling. That is another way of doing it. Or you can also combine auto scaling and code deploy, and also you can do it.
Okay.
Still initializing. Okay, it has launched another instance here. But still initializing. But customer will not definitely feel any impact because it's connected to the load balancer, right? So number of instances that are getting added and that is getting subtracted in the background. Customer would hardly have an impact here, right? Now both the machines are running now. Now in the second example, I'm gonna artificially create a stress so that you can see a third machine is automatically added here, right? I'm gonna go here, execute, and I'm gonna add 70% stress here. And by the way, this is another way of doing it. I've created a stress right now. A third machine should be added. I think it will take 30 seconds for the machine to be added. Okay, so launching another instance. This message has popped up, so just launching another machine now. And the machine should show up here in a moment. And if you see, a new machine has added. By just simulating a stress in the scaling policy, a new machine has added.
Are you going to cover the Kubernetes as well, or just the Docker? That's the finish.
Or just Kubernetes also can be done, but I would encourage you to teach me Kubernetes. Right, go explore it, and can you do me a lab and can you share a videos with us?
Still, the Docker for the AWS is little bit complicated. It looks like, because I know about the Docker how we can able to do it.
No, yeah, it is.
Yeah.
It is 100 times simpler than the traditional Docker work that you do in your traditional data center, right? So if you want to do Kubernetes, Elastic Kubernetes service is available here. You just click on the Kubernetes here. Go to Virginia. It is not available in Mumbai. Right, Elastic Container Service for Kubernetes. You give a cluster name, and then you do next finish. A Kubernetes will be created. It is even more simpler than Elastic Container Service. Right, so give it a try. Record a video, put it in your YouTube channel, and you can share it in your Slacks so your seniors can see and you can also see. But I'll try to show you some of the AI labs, right? You might be interested in out of syllabus, but it'll be fun, you guys learning and knowing what is happening with AI on AWS. But Kubernetes is fairly new. It is new for me also. It was recently launched like a couple of weeks ago, right? They will not ask you in your examination, but I would encourage if you could cover that and if you could show us over a video or something. 5 minutes video is fine. Right, so if you see here, 3 instances are there right now because of auto scaling. If you go back to my load balancer and my target group, there you go, 3 instances are added. Right, now I'm gonna remove the stress, go to action, execute, and I'm gonna say bring the stress below 40%, execute. Now what will happen is, see if it terminating, the terminating process started, where it will drain, it will remove this instance from the load balancer, and then it will delete that instance. So auto scaling does not mean that you increase the CPU memory on the same instance. Auto scaling means adding more instances to the mix. Making sense? So Mahesh, can you do it? Is it possible?
I can do it. Yeah.
Excellent. Hey, how do you call from there to India here? Do you use a VPN or something to make a call? Or you
No,
just simply call from WhatsApp?
no, I directly call from my mobile because it's just 1 cent for me from calling to Mumbai or India.
Where are you right now? You're in
Dublin.
US,
No, Dublin.
UK, Ireland,
This
Europe.
side, yeah, Ireland.
1 cent or 1 pound?
1 cent.
How much is it in according to
100.
Indian money?
100 cent is equal to €1, and €1 is equal to 80 rupees.
So how much you're paying? 80 paisa per minute.
Around, yeah.
Okay. It is not terminating. What could be the problem? Refresh. Okay, it is draining the traffic from the load balancer. So that means I have to check the load balancer, whether the load balancer is holding up to this instance. Okay, if you see here, the message says draining. So it is removing the traffic from the load balancer before it is bringing the server down. Let's give a couple of more minutes. Let me do a refresh. Still nothing. It is still draining. Okay, it is still draining.
Generally, it will take 2 to 3 minutes to terminate or
Usually,
start.
usually it will take 1 minute, 1.5 minutes to come up and about 1.5 minutes to come down. I think it is just exception. It is playing games with me, I guess. It doesn't want to see me being peaceful here. Right. So sometimes it takes some time. I think the load balancer is holding up to that instance. The traffic has to drain. So we'll wait. I know it is boring, but we will wait. Waiting for ELB connection to drain. Target deregistering is in progress. Okay. Finally it is shutting down now. Finally it is shutting down. It took really long. Okay, in progress, the termination in progress. Finally the load balancer drained. And there you go, boys. So this is how you can create an auto scaling where you can give min max configuration and let the system know how you want to set up an auto scaling. Again, it all works with the template that you have created. Going back to a previous discussion, if you have a version 2.0 or 3.0, you can always go back and edit a load balancer group and change the image, right? Or you can also create another auto scaling group and you can use the same load balancer. You can have two auto scaling groups and you can use the same load balancer, and then you can delete the old auto scaling group once the new auto scaling group takes over. That is one way of doing it. The second way of doing it is you can use code deploy along with auto scaling. That is another solution that you can work with. And if you have any other ideas to use the new version or along with an auto scaling, we can discuss on that. So this concludes today's lecture. So you guys discuss among yourself and let me know if you want to have a class tomorrow. I'm okay to take your class tomorrow. If nobody comes up with anything, then we will have a class tomorrow. But majority of you say no class, then we will not have a class tomorrow. So before I pack up the class for the day, do you guys have any questions? Can we have a class on Tuesday? I'm fine with that. Next to UK. All right then, so we have no class tomorrow and we will have a class on Tuesday. All right then, so I will see you on Tuesday. Thank you for joining, boys, and please do your lab and update me. Thank you very much.